Let's calculate the volume of a sphere of radius a using polar coordinates. First thing to remember is the equation of a sphere of radius a is x squared plus y squared plus z squared equals a squared. Now, we're going to do this by looking at the upper hemisphere and the lower hemisphere. So if we solve for z, we'll get plus or minus the square root of a squared minus x squared minus y squared. The plus minus corresponds to the upper and lower hemispheres. So let's find the volume of the upper hemisphere and then we'll double it. So volume of the upper hemisphere will be a double integral of the positive square root of a squared minus x squared minus y squared over some region. The question is, what is the region? Take a moment and think about it. The region R is this circle of radius a in the xy plane. And here I've rewritten the integrand in green, and I'm just going to trace over this upper hemisphere with green as well. So what we need now is to describe the region R in polar coordinates. The region R is a circle of radius a. Well, we need upper and lower bounds for R, upper and lower bounds for theta. Theta evidently ranges from 0 to 2 pi, and R ranges from 0 to a. So now we need to re-express the integrand a squared minus x squared minus y squared in terms of r and theta. If you replace x with r cos theta and y with r sine theta and then simplify, this becomes, I'll leave it to you to verify, you simply get a squared minus r squared. And then, of course, you remember that the infinitesimal area in polar coordinates is r dr d theta. So this double integral then here becomes the double integral of a squared minus r squared times r dr d theta, where r ranges from 0 to a and theta ranges from 0 to 2 pi. Now to evaluate this, we're first going to integrate with respect to r, and we see that r appears here as a factor here and then also under this square root. Take a moment and think about how you would integrate that, a function of that form, if you encountered it in a first-year calculus class. We can do it by using substitution. So let's let u be a squared minus r squared. So then du will be minus 2r dr. In particular, r dr, which is what we see under the integral, will be minus a half du. Now, if u is a squared minus r squared and r ranges from 0 to a, then u is going to range, well, when r is 0, u will be a squared, and when r is a, u will be 0. So this is going to become the integral from a squared to 0 of the square root of u minus a half du d theta. So now let's work out that integral. This will be simply u to the power of 3/2 times a factor of minus a third. And that will get evaluated at a squared and at 0. So we'll have, plugging in 0 will give 0, then subtract from that, what you get when you plug in a squared. You get 1/3 a cubed. And this we evaluate or integrate with respect to theta. And what you'll get is 2 pi over 3 a cubed. Now, remember, that was the volume of a the upper hemisphere. Volume of the hemisphere. So, to find the volume of the sphere, you double it. The volume of the sphere is 4 pi over 3 a cubed.